Hello and welcome. In this video, we'll begin to talk about the collection of variables. So let's start with Google Colab and let's create a new notebook. It's not that we have to create a new notebook for every other task. You can continue to work on the same one. In case you've landed here as your first video, you probably would need that, and that's why I'm doing it. So I'm going to just rename this to collection of variables. And the first one that we want to learn is known as a list. I'm just calling it by the name of list one. And let's say it stores some value. So far, we've seen one value, which we were calling as a variable, right? What if we have a collection of variables? So we're writing 1, 2, 3, 4, 5. Now, inside these square brackets, when you put these values, these are known as the list types. So let's just execute it. It is not necessary that it has to have only ints or floats or just one data type. It can actually be a mix of different data types as well. So I'm creating it by the name of list2, and I'm writing, let's say, Sam as one of the names, and I'm writing the values as 2, 20, and also 10.3. This is also a list, though it is not very common to see a mixed types, but it is possible that a list can contain mixed data types within these square brackets. When it comes to list, there is something that's known as indexing. So let's say I want to access the first item of list 1. Python follows zero indexing. So the counting starts from 0. When I want to access the first item, I will write list 1 and square bracket 0. This is a way to index it. So it returns 1. If I want to access the first item of list 2, same way, I will use 0 and it will return Sam. If I want to access the value 20 in list 2, I will simply write list 2 and the index will be 0, 1, and 2. It is the third value, but index is 2. It takes some time to get used to of this, just a little bit of practice. Lists also allow us to do negative indexing. So if I want to access list 2's last element, I can write -1, and that will return the last value of the list. If we want to access multiple values, we can use something known as the slicing. So let's say I want to take the last 3 values of list 1. So I can start from the value that I want and just put a colon if I want to go over till end. So it will be 0, 1, and 2. So if I say 2 colon, it means it's going to go over the entire length, 3, 4, and 5. However, if here I would have written list 1 values from 2 to 4, it will only return me 2 values. The upper value when you're indexing here is not counted. So this is slightly tricky, takes a little bit of time, as I said, to understand initially. So when you put a slice starting from 2 and ending at 4, 2 will be inclusive and 4 will be exclusive. So if I execute this, it will only take the index 2 and 3. Index 2 was 3 and index 3 was the value 4. So it only returns these values, it doesn't go to 5. One way to do this is you can increase this by one more number, and now it will take index 2, 3, and 4. So let me run this, and now it's returning 3, 4, and 5. Or the easier way was just to put the value that you start from and put a colon, and you get it. Let's say you wanted to get some values in the middle. Let's say from the list 2, you wanted to get the values which are 2 and 20, right? So how would you get these? We want to get the middle two values. The first value is index 1, and the second value is index 2. So that should be easy. We'll not put just 1 and 2. 1 and 2 would mean that it's only including 1 and not 2. So let's now put 1 colon 3, and that means 2 and 20. These were the middle two values in your list. So this is called indexing and slicing on a list. Similar to list is something that's known as tuples. And tuples are values contained between the parentheses. So let's say I write 2, 5, 3, 10, something like this. I'm calling it tup1. That's the name that I'm giving. And if you want to do indexing on a tuple, you can do tup of 2. That's again going to be the same thing. It's going to return the value 3. Why? Because 0, 1, and 2. That's the value 3 here that it's returning. So the indexing works the same way as that of list. The major difference is that tuples are immutable. What does it mean? So if I was working on a list, let's say I bring the list 1 once again here, I see these values. And let's say I want to change this value in the middle with a number 100. So what I can do is I can say list 1, and I have to give the index reference. So 0, 1, and 2, I want to change this with 100. Now if I check list 1, you can see this value has been overwritten. However, if I try to do the same thing with a tuple, it won't be allowed. Let's try this. It'll give an error. So when I say tup1 and I take the value, let's say I want to overwrite the value 5 there with 100. So 5 is index 1 second position. If I want to change this with 100 here, it's going to give me an error. So depending on the application, there are times when people would prefer to work with tuples when they don't want the values to be overwritten. Otherwise, they can continue to work with lists. Similarly, we have something known as a dictionary. So I'm writing it by the name of DICT1, and this is contained in the curly brackets. It works in the form of key and value pairs. So we can define, let's say, names. So let's say there's somebody by the name of Sam whose score is 90. There's another person by the name of Joy whose score is 85. And then we have one more person, which is, let's say, Alice, and her score is, let's say, 72. So this is a dictionary notation, and this works in the form of key value pairs. This is a key which stores a value 90. So if I write DICT1 and I write the key instead of the index, I write the key, let's say Sam, it will return me the value that's stored in the key. Not only this, if we want to extend these values in the form of a list, it can also store a list. So for example, if I want to extend this for Sam, let's say I want to store multiple scores of multiple subjects, let's say 90, 98, and 100, let's say. Let's say we have 85, 92, and 90. So now we are storing a list here, right? And if I store multiple values, 85 and 90 here, so this is going to overwrite, but if I now check the values corresponding to Sam, I'll get all the values. This can also work with specific methods that are associated with it. So if I want to check what are the keys available in the dictionary, I can do keys and it tells there are 3 keys available. Imagine you can have a lot of data. It can range into thousands of values. So if you just want to check the keys, you will get the keys available. And if you want to now pull out the information that's specific to Sam, you can use the right key and get the value, right? Same way for the dictionary, you can also access the values if you want to access all the values at once. So you can get that, right? Shows all the values available in the dictionary. And if you want to check what are the items present in a dictionary, you can just write items. So this is kind of showing you what all key value pairs are present in a dictionary. The last one on our list is a set. So let's say I call something as a set 1 and I put it in the curly brackets. Let's say I put the values, let's say any number of values. So I write 1, 2, 2, 3, 4, 5, 5, 7. This again uses curly brackets, but here we don't really have key value pairs like dictionaries. How is set different from others? Let's just see. It returns only the unique values to me. So there were a couple of repetitions here. If you notice, it has on its own ignored it. It is not ordered. If you want to do indexing on this, let's say you want to do set 1 and put a 0 here, it returns an error. It says it does not support indexing. Just like you could do indexing over list and tuples, it's not possible. So if I were to give you a quick comparison table between these 4 variable collections that we talked about, here's how it is going to be. So a list is mutable and is ordered, put under square brackets. A tuple is not mutable, it's immutable, it's ordered, and is represented by these regular parentheses. Dictionary, on the other hand, is mutable. Now, this is tricky. We will probably be discussing it at length in a future video, but for now, just take it that the dictionary is mutable and it is not ordered. If you try to do indexing on this, you will get an error message. Dictionary is typically in the key value pair format. We've seen an example earlier. Last one is set, and sets are mutable but unordered, and they result into unique values. That's it for now. We'll be coming up with more foundation related videos in future. Thank you.